Good day, cretans. Welcome to our lesson. I am Skulile Ncube, and this lesson is proudly brought to you by the Gauteng Department of Education. How are the examinations, cretans? I really hope that you're managing and you're passing. You're doing very well, isn't it? Okay. Right. Today, cretans, we're going to look at probability. Do you know probability? Right. We're going to look at mutually exclusive and complementary events. Mutually exclusive and complementary events, and we're going to use Venn diagrams when explaining these two types of events. Okay, right. So you're going to even learn about the Venn diagrams. I'll show you how to to represent events in a Venn diagram. Are you ready? Right, please write today's date, even the topic, and make sure you're ready, your books with you there. Okay, you're not going to just sit and listen to me. You cannot learn like that. You have to You have to write, okay? I'm giving you activities to do. Remember our WhatsApp line, 079 454 9535. Remember the line, you can ask questions. If I'm moving fast, you tell me, say, slow down. Right, you want to send us your work, you can take a picture and send us your work. Any input that will make our lessons better, please do so. Send those inputs, okay? Right. And then at the end of the lesson, you should be able to define sample space. Define sample space. We're going to interpret Venn diagrams. We're going to draw Venn diagrams. Especially, we're going to start by drawing and then interpreting. We're going to derive the addition rule for inclusive and mutually exclusive events. And then we're going to define complementary events. We're going to understand what complementary events are, what mutually exclusive events are, what exhaustive events are. Okay? Right. Now, so we have done probability in the previous grades and also counting. There's a lot of counting when it comes to probability. Right, before we move any further, I want you to try this. This is a baseline activity. I want you to try. And I'm going to give you 5 minutes, okay? Right. A die is thrown. Oh, some books they say dice because in real life we say dice. But actually, when it's one, we say die for singular and then dice for plural, for many, okay? But I'll be using these terms interchangeably. So if I say die, dice means the same thing. So a dice is thrown, the possible outcomes, which is the sample space. How many do we have? You can get a 6, or let me start with the smallest one. You can get a 1, you can get a 2, you can get a 3, a 4, a 5, or a 6. These are different outcomes that you can get if you throw a die. Right, so there are 1, 2, 3, 4, 5, 6 outcomes. If the event A is getting a number greater than 2, if I'm saying a number greater than 2, it means I want a number that is greater than 2. Okay? It can't be 2. I want a number that is greater than 2. And event B is getting a number less than or equal to 2. Calculate the following: the probability of getting A, the probability of getting B, the probability of getting A and B, the probability of getting A or B. I want you to try that for 5 minutes. Let's try. Welcome back, grade 10s. Let's see, did you manage to get it right? Let's mark our work. Right, what is the probability of getting A? Now we're looking at the favorable outcomes, what we want. Event A, we want numbers that are greater than 2. And then these are the numbers, which is what? How many? 1, 2, 3, 4. Out of how many possible outcomes? Out of 6 possible outcomes. So we're saying that the probability of getting A is 4 out of 6, which is 2 over 3. Okay, mark that. Okay, right. So probability of A is the number of the outcomes that we want, the favorable outcomes, divided by the number of items in the sample space, which is all the possible outcomes. If you throw a die, there are 6 possible outcomes, so that forms the denominator. And then the numbers that are greater than 2, there are 4 of them, that forms the numerator. So 4 out of 6, which is 2 out of 3, when you reduce to lowest terms. Okay, now if you think you can do B, you can just correct your work very fast while what I'm explaining. We want the probability of B, getting event B. What are the outcomes here? You can get 1 or 2. So the probability of getting a number less than or equals to 2. So it means 2 is included. So it's 1 or 2. So there are 2 favorable outcomes out of the total possible outcomes. Okay, so it's 2 out of what? If you throw a die, how many possible outcomes are there? There are 6, isn't it? So it's 2 out of 6. And then you reduce it to 1 over 3. And then the probability of getting A and B. What is the meaning of this? Right, let's say you are in a class or in a lesson. Now I know you're math learners only, but let's say now you're in a math, maybe let's say what? English, first additional language lesson. You're mixed there, isn't it? Okay, maths and maths lit. If I say I want the learners that are doing pure mathematics and mathematical literacy, how many learners will stand up? I want learners who are doing mathematics and mathematical literacy. How many learners will stand up? No one will stand up, isn't it? Because there's no one who's doing mathematics and mathematical literacy. Okay? But with other subjects, you may find that is possible. If I would say, I want learners who are doing geography and physical sciences, you may find that there are learners who are doing geography and physical sciences, but there are also learners who are doing geography only, and there are also learners who are doing physical sciences only. You see that? Okay. But now I'll tell you what type of events these are, whereby there's no overlapping. We don't have a learner that is doing mathematics and mathematical literacy. Okay, right. And then now, so do we have an outcome here, which is in event A and event B? Do we have? We don't have. You see that? There's no outcome that is in event A and event B. So it means here, probability of finding A and B is not possible. It's 0. It's a null set. Null set. Okay? Like null. Null set is 0 or just equal to 0. That's fine. That's enough. So there is no intersection. We're going to discuss that as we discuss what? The Venn diagrams. Okay? Right. I will use this example throughout of mathematics and mathematical literacy. Right, let's go to D. Now, if I come back to you again and say, I want learners who are doing mathematics or mathematical literacy. I want you to see the difference between and or. I want learners who are doing mathematics or mathematical literacy to stand up. How many learners will stand? Everyone is going to stand because everyone does mathematics or mathematical literacy. You see that? So this is the union of the events. Union of the events. So it's all the outcomes in A and all the outcomes in B. So we have got all, how many outcomes combined, A and B? There are 6 of them. So the probability of A or B will be 6 over 6, which is 1. And 1 means 100%. 1 means it's definite. If I say I want learners who are doing mathematics or mathematical literacy, or everyone is going to what? Stand up. If I say you must stand up. You see that? See the difference between and or. Okay? Right. And then let's try to understand our Venn diagram now before we look at some examples. The sample space is the set of all possible outcomes. Like there when you throw a dice or a die, the sample space is all the possible outcomes, the 6 of them. That is the sample space. And then from that sample space, we can have outcomes which are even numbers. We can have outcomes which are odd numbers. We can have outcomes that are greater than 1. We can have outcomes that are maybe less than 5. Okay, from that sample space. Usually a rectangle is used to represent a sample space. We're going to be drawing our Venn diagrams. So the sample space, we use a rectangle like this, and then we write S there for sample space. And then usually the circles are used to represent events within the sample space. So in the sample space now, the events are there. We have the sample space, which is the outcomes we get when you throw a dice. I'm using this example. And then the events may be getting odd numbers. The other event may be getting even numbers. They are inside the sample space. You understand? Okay. Like let's say in your class there, let's take for example a class. There is sample space. That is sample space. Let's say this is 10A. It's everyone there. What is the probability of picking someone who's doing tourism? That's an event. Picking someone who's doing life sciences, that's an event in the sample space. Okay? Right, so these are the events there. Right, and then we're going to be writing short notes. I'm going to show you how to write these short notes so that we don't waste time. Please don't use rulers because we won't have time to be drawing. But if you can do it fast, it's fine. But let's try to be neat with our free hand. Right, so here event A is in sample space. We see that is event A in sample space. Right, what we have here, we have event A and B in the sample space. What can we say about these two events? So event A and B in sample space S, and then events A and B have no common values. That's why they are not overlapping. We don't have intersection. We don't have common values. They are not overlapping. Okay? Right. What else? A and B are disjoint sets. Disjoint sets. So I want you to just write this. Draw your Venn diagram like this. Just draw as I draw like this. And then we have A, we have B. Don't write everything. Just say disjoint sets. Just that is enough. Okay, disjoint sets. Just do that in 30 seconds, and then we move on after that. We're going to be drawing, there's a lot of them. We have a lot, maybe 9 or so. Okay, right, so we have to move fast. Otherwise, we won't learn a lot if we waste time. Right, let's move on to the next one. Okay, this one. What can you say about the events A and B here? They are overlapping. They are overlapping. What is the meaning of that? It means we have outcomes that can be found in both A and B, represented by this shaded region here. It means we have an outcome that can be found in both A and B. Okay, right. So events A and B have common values. A and B intersect. The intersection of A and B is written as A and B. So let's just write this. We don't need to write a lot of things. Just follow what I'm doing here. Then you have event A, we have event B. Then this shaded region means A and B. Means A and B. It means these are the common outcomes that are found in A and B. Okay? Right. We're looking at what does this shaded region represent. What does the shaded region represent? Okay? Right. Copy that first. And then we move on. We have a lot of them, I told you. Right, this one, what do you think about this one? What is the meaning of this? The shaded area is the combination or union of event A and B. It's a combination, union. Remember, I said that if I say those who are doing maths and maths lit, stand up, everyone is going to stand. It's maths lit or maths. You see that? That's the union there. So, and then what else? Union of event A and B is written as A or B. You see the use of and or. Okay, the difference there. And then let's just draw our Venn diagram. I'm forgetting to write the sample space S there. Please correct that. Everywhere, just write S there for sample space. And then make sure you write there sample space. And then this is A, this is B. And then this is the shaded region to show us that this is A or B. That's union. Union. And then and is an intersection. You can even write that. And means intersection. Or means union. Okay? Combination of the events. Okay? Right. Let's move on. Just use freehand neatly. And then maybe later you can what? You can write your neat notes using rulers and everything. Okay? Right. What about this shaded region now? It's outside the events A and B. What do we say? Right. The shaded area is in neither A nor B. Not in A, not in B. So how do we write that? We say not in A or B. Okay? So just draw like this. Let's move together so that when I finish, you're also finishing. Sample space. This is A. This is B. Then we're shading outside. Okay, outside. Done. Then this means not in A or B. Not in A or B. Okay? That's what it means there. Not in A or B. Not in A, not in B. Okay? Right. What about this one? What do you think? What does the whole circle of A represent? It means these are the events that are found in A, including the ones in the intersection. But now we've just shaded the part which does not include the intersection. What does that mean? It means what? A only. A only. A includes the intersection. So it means if I'm saying A, I'm also including the intersection. You see that? But A only does not include the intersection. That's the shaded part. So that is A only. Okay, let's just do this. You're also drawing, isn't it? Okay, don't wait for me and sitting there doing nothing. So this means A only. Can I think of an example? Let me see. I'll see if we will use our subjects that we're doing. Okay, A only. Right, let's think of an example. Right, let's say I have a Venn diagram like this. Let's say which subjects? Like L for life sciences. Let me put L here. And then P for physical sciences. Okay? Right. And then we have intersection, let's say 10. And then here, L only means life sciences only, let's say 5. And then physics, let's say what? 11. And then let's say we have 2 there. Okay? Right, if I may ask, how many learners are doing life sciences and physical sciences? How many learners are doing life sciences and physical sciences? There are 10 learners. These are the learners in the intersection. And then how many learners are doing life sciences or physical sciences? Life sciences or physical sciences. We have to add this 5 plus 10 plus 11. So it means that is 21, 26 learners. How many learners altogether? We have to include even these ones which are not doing physical sciences and not doing what? And not doing life sciences. These two. They are not doing physical sciences. They are not doing life sciences. You see that? But they are in the sample space. Right. How many learners are doing life sciences? We have to include these 2 and these 10. There are 15 learners doing life sciences. But 5 learners do life sciences only. And then 11 learners do physical sciences only, but 21 learners do physical sciences. Do you see that? Okay, right, perfect. If there are any questions, please send them 079 454 9535. Right, what about here? This one is just similar to what we just discussed. This is B only. We don't need to write this. It's represented by what we just wrote there with A only. So it's repetition, isn't it? Okay, this means B only. What about this one? Now there are 3 sets now. A, B, and C. The shaded region. What does it represent? It represents A and B and C. Okay, I've shown you how to draw these diagrams. Should I keep on repeating? Let me just give you time. Now you know how to sketch your diagrams. And then just write this. Okay? Let me give you 1 minute so that you can also, if you maybe you're trying to catch up, you can. 1 minute. Let's try. Right, welcome back. Let's do the last one. It should be the last one, the last diagram. What do you think about this one? If you look at the shaded region, what do you think? It's going to be A or B or C. Okay? Yes, just copy the diagram. I'm going to give you 30 seconds now. I'm not going to go anywhere. I'll wait for you. So copy this and then write A or B or C. For shading, just use this. Don't shade like you're painting. Ne? Just do this. It's enough. It's enough. Okay? Right. And then you write A or B or C. Then we'll be done. Okay? Then we move on to the next thing. A or B or C. Okay, right. If you manage to write, right, perfect, perfect. Okay, you think you understand? Please, if you don't understand, send us a message so that we can maybe send. Don't send a question and say I don't understand. Just send a specific question. Say this one. I don't understand this one, so that we can what give you the appropriate answer. Okay, right now. And then, oh, there's another one. Okay, let me just, this one is A only. It's just the same thing, A only. Let's go back there. This means A only. And then these ones, they are doing is A and C. These ones, A and B. These ones, B and C. And then these ones, A, B, and C. Okay? Yeah, right. Now, let's look at these ones. Represent sets of events using Venn diagrams. How do we do that? Let's go back to our example or the use of a dice. Sample space outcomes when rolling a single dice. You can get these 6 outcomes. These are the possible outcomes. And then event A is getting an even number. An even number is a number that is divisible by 2. And then B getting a factor of 6. Do we know the factors of 6? It's 1, 2, 3, 6. Right. Now, let's look at these two events. Do we have outcomes that are common, that are found in event A and event B, that are found in event A and event B? Okay, and in capital letters. Do we have such outcomes? Yes. 2 is there, 2 is there. Then 6 is there, 6 is there. So where do we write these outcomes? If you check on the Venn diagram there, at the intersection where the two events overlap, because these two outcomes are found in both events. So we have 2 there and 6. Right. Let's fill in A now. Are we going to write the 2 again and the 6? We can't do that. We want to have A only now, which is found in A only. That is 4. You see that? 4 is not a factor of 6, but it is what? An even number. But 2, it is a factor of 6. It is even number. 6, it is a factor of 6. It is an even number. You see that? And then B, getting a factor of 6. Do we have a number which is a factor of 6 but not even? Yes, we have. So we have there 1, it's a factor of 6 but not even, and then 3. Do you see that? That is our Venn diagram. That is our Venn diagram. Okay, so we're not going to write notes every time, because if you do that, we're going to waste a lot of time. So some of them I'm going to give you time to write notes. Some of them I won't give you, so that you can cover maybe more things. Now, let me give you 1 minute for this one, because it's the first example. Let's try to copy just short notes. Don't need to write everything. Just sample space and the outcomes, event and outcomes, event and outcomes, then the Venn diagram is done. Let's do that in 1 minute. Welcome back, cretins. Let's move on to the next part of our lesson. Oh, I forgot. How did I do that? Oh, we didn't. That's a serious mistake. There is a 5. Okay. Oh, that's a serious mistake. Right. We didn't even count our outcomes there. We said 1, 2, 3, 4, 5. We're supposed to do that. Now, there is 5, which is not in A and not in B. Please correct that. Please correct that. 5 is not in A and 5 is not in B. You see that? Okay, very sorry for that. Okay, right. Make sure that everything in the sample space is in the rectangle. Okay, everything in the sample space must be in the rectangle. It can be out of the events, but it must be in the rectangle. Okay, right. Now, Oh, let's go back. I want to discuss this before we move on. Right, events like this, you can even write short notes. They are inclusive events. They are called inclusive events. Okay, so this is an example of inclusive events. And inclusive events have what? Have intersection, they overlap, they have common outcomes. Those are inclusive events. Okay, please just write inclusive events. And then still we're throwing the dice. And then now the events is getting an even number. Event A getting an even number. Event B getting an odd number. Okay? Right. Now, if you check, even numbers, we have the 2 there, the 4, the 6. These are the outcomes. So when you're counting them, you count 1, 2, 3, like that. These are the items that we're counting. And then getting B, we have 3 and 5. We can't make the similar mistake now. What is outside these two events? Which is not an even, no. This says getting an odd prime number. An odd prime number. Okay, right. Which number here in this sample space, which is not an odd prime number and also is not even? It is what? 1. Do you see that? 1 is not a prime number, is not even. So it is outside the events, okay? So let's check if we have all the outcomes from the sample space, or all the possible outcomes. 1 is there, 2 is there, 3 is there, 4 is there, 5 is there, 6 is there. So we have everything. What type of events are these ones? We say they are disjoint sets, okay? So they have a special name that we're going to talk about. They are called mutually exclusive events. Just write that, mutually exclusive events. For mutually exclusive events, the probability of A and B is equal to 0, okay? Where they don't have anything common. There's no common outcome between event A and event B. They are called mutually exclusive events, which is the opposite of inclusive events. Okay? Right. And then I'm trying to move slow. Please try to use the time to also write short notes. And then now, we have these events. We're still throwing a dice. And then we have events of getting an even number and then getting numbers that are greater than 1. Numbers greater than 1. So if you check, all these numbers are found in event B. So what do we say here? We say event A is a subset of B because it is found inside B. It is a subset. Do we have all the outcomes? 1 is there, 2 is there, 3 is there, 4 is there, 5 is there, 6 is there. You see that? That's a subset. Okay? Right, let's move on. You can write short notes if you can, but if you couldn't write any notes, it's fine. Let's move on. Right, derive the probability identity. I want us to derive this formula. It is very, very important in probability. You hardly find a paper that does not have this addition rule. I'm telling you in the examination, if you haven't written them, you're going to find this. Okay, so probability of A or B is equal to the probability of A plus probability of B minus probability of A and B. And then we're going to use this example to prove that. We're going to prove that this left-hand side is equal to the right-hand side. Can we do that? Right, we're going to do it step by step. We're going to do it step by step. Right, what is the probability of A or B? What is the probability of A or B? Say it in the classroom there. What is it? A union B. Everything that is found in A and B is what? 5 out of 6. Good. So we have 1, 2, 3, 4, 5 items. So out of 6. So it's 5 out of 6. What is the probability of A? The whole A, not A only. Please, there's a difference between A only and A. What is the probability of finding probability of finding the outcomes in A? It's not 1 out of 6. That is A only. So it's going to be, let's count, 1, 2, 3. So in A is 3 out of 6. Okay, which is half. I'm not going to reduce them to lowest terms because I want the, what we call this, the denominator to just be the same. If I reduce it, I can find that now I have 1 over 2, and then the other one is 1 over 3. Now I have to go back and get the LCD, which is 6. No, let me just leave it like this. Okay, 3 over 6. Now, that's the probability of A, done. What is the probability of B? B, the whole B, not B only. B only will be 2, isn't it? Because there's 3 and 1 there. But B is going to be 4 out of 6. Okay, let's leave it as 4 out of 6. That is B. We've done this part. And then what is the probability of P? Probability of A and B, the intersection. How many items do we have there? We have 2 out of 6. You see that? Okay, I want us to substitute what we have here. We have everything. We have everything. This, we have this, we have this, we have this, we have. Let's substitute these things into this and see if the left-hand side is going to be equal to the right-hand side. Let's just do that. So I've substituted here, okay? Right, if you can even use your calculator here. Oh, you don't even need a calculator. What is 3 plus 4? 3 plus 4 is what? 7, isn't it? Then what is 7 minus 2? Is 5. You see that? So we're getting 5 out of 6. You see? So we've proved that this is equal to this. Please write it down for 1 minute. I'll give you 1 minute. This is very, very important. Write it down. Right, welcome back, grade 10s. Now we have learned about this probability identity or the addition rule. Right, so now, so we previously discovered that for inclusive events, remember we talked about inclusive events and exclusive events, isn't it? The addition rule is this. We just did that now, just now. Remember, grade 10s. Inclusive events are events that have common elements that overlap. Probability of A and B, there is a value for it, which is not 0. Okay? They have an intersection. So what do you think will happen to this formula if we talk of mutually exclusive events where the probability of A and B is 0? What is going to happen? Let's find out. Let's find out just now. So mutually exclusive events are events that cannot occur at the same time, events that do not intersect or have any elements in common. If we are using event A and event B, we're saying event A and B is equal to 0. The probability of getting event A and B is equal to 0. The probability. You want to see P there, means probability. Okay? Right. So now, what will happen to our formula now? Probability of A and B is 0. So what will happen to our formula? Does it change? A bit. It is going to change a bit. So where there's probability of A and B there, we put 0. And then what is going to happen? We put 0 here, and then we just have probability of A or B being equal to probability of A plus probability of B. Right. This is for mutually inclusive events. This is for inclusive events, sorry. This is for inclusive events. This is for mutually exclusive events. So write this formula that I've circled here and say mutually exclusive events. Okay? Because for mutually exclusive events, this is equal to 0. So it disappears. Then we remain with this. For mutually exclusive events, write it down for 1 minute. Right, welcome back, grade 10s. Now, consider the sample space. Now it's something different. The sample space is different. We've been using the dice. So the sample space now is having the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, event A is drawing a number less than 5. And then event B is drawing a number greater than 5. Drawing means it's like not drawing like doing art, no? You take it out. Let's say there's a bag or something, and then inside there are numbers. If I say draw a number, mean take the number out of the bag. That's drawing, isn't it? Okay. Right now, so it means 5 is not in event A, 5 is not in event B. Okay, you see that? So these two events, they don't have anything. They don't have a common outcome. So they are mutually exclusive. So we can use our formula, probability of A or B is equal to probability of A plus probability of B. Just like this. Then we get our probability. You see that? There's only one number which is not in the event. The other 9 numbers are in A or B. So the probability of getting A or B is just 9 over 10. You see that? Okay, right. And then it's an example. You have your notes, it's fine. We're going to use your notes later, isn't it? After this, you're going to go to your past examination papers, try to apply what you have learned. Okay, don't just end here. Close your books and then you come again next week. No, you continue revising, look for past examination papers if you can get, and just try to apply what you have learned in this lesson. Right, I want us to do this. I want you to do this. I'm going to give you 5 minutes. Okay, we're left with a few minutes, but if you do this one, at least it's fine. In a class of 30 learners, 4 take both life sciences and physical sciences. 18 take life sciences. Life sciences, let's call it event A. Life sciences only. 11 take physical sciences. Let's call taking physical sciences event B. And then 1 takes neither life sciences nor physical sciences. Means not in life sciences, not in physical sciences. Draw a Venn diagram for these events. Let's do that. I'm going to give you 5 minutes. And then try to get this one right. And then after that, we'll be left with a few minutes. We can try to do whatever we can do in those few minutes. Then we summarize. Let's have our 5 minutes and do our work. Right, welcome back, grade 10s. Let's mark our work. Right, this is our Venn diagram now with our events A and B. It says you have to start with the intersection. Now there are 4 learners that take both life sciences and physical sciences. Then we put them there by the intersection. It means 4 learners, okay? Right, mark that if you got it right. And then 18 take life sciences. 18 take life sciences only. Oh, there's only here. Very important. So 18 take life sciences only. This is the part where we talk about life sciences only here. So this is the 18 there. Okay, so it means how many learners do life sciences altogether? 22 learners do life sciences, but 18 do life sciences only. And then 11 take physical sciences. We're not told that physical sciences only. They said 11 take physical science. It means the whole circle should be 11. So what is physical sciences only? It's going to be 7, because it's 7 plus 4, which is 11. Okay? Right. Do we have anyone? 1 takes neither. Okay. Let's just take a short break, then we'll come back. Just 1 minute. Right, welcome back, Cretans. So we're saying that 1 takes neither life sciences nor physical sciences. So this one is out of the events. Okay, so we've answered our question because they said draw a Venn diagram. Now let's just answer a few questions now using our Venn diagram. So determine the probability that a learner selected a random takes life sciences as a subject. What is the probability there? Let's say the answers, you don't need to write them down. So it's 22 out of 30. 22 out of 30. These are the learners that are doing life sciences. 18 plus 4. Right. Determine the probability that a learner selected a random takes physical sciences as the subject. Physical sciences as a subject is going to be 11 out of 30. Remember the 30 learners. Even if you add this, you'll get 30 there. Okay. Right. Determine the probability that a learner selected random takes both physical sciences and life sciences. I said say the answers. Just say them. How many learners take both physical sciences and life sciences? Or the probability that a learner selected a random takes both physical sciences and life sciences is what? 4 out of 30. Okay, these are the learners that are taking both physical sciences and life sciences. Determine the probability that a learner selected at random takes either physical sciences or life sciences. Either physical sciences or life sciences. What's the probability there? We are looking at this region here. A union B is going to be 29 out of 30. You see that? So we have 1 here. We can also say 30 over 30 minus 1 over 30, which is 29 over 30. Okay? Right. And then Determine whether the events are inclusive or mutually exclusive. Are they inclusive or mutually exclusive? I'm going to say they are inclusive. They are inclusive. Why? Why are they inclusive? Because the probability of A and B is not equal to 0. Okay? It is 4 out of 30. Events are inclusive. Okay? If events A and B cover all elements of the sample space, they are said to be exhaustive. Let's go back to our example of mathematics and mathematical literacy. Those two events are exhaustive because if I say learners that are doing mathematics and mathematical literacy, is everyone in the class. If I say mathematics or, sorry, not and, mathematics or mathematical literacy, is everyone in the class. Everyone in the class is doing mathematics or mathematical literacy. So these events that take everything in the sample space, they are called exhaustive events. What is to exhaust? You finish. You see, that's exhausting. And then we're just finishing. So exhaustive events, the probability of A or B is 1, isn't it? And then we have, okay, let me just tell you about these events. Not to worry about a lot of things. We're finishing. And then we have events that are mutually exclusive and are also exhaustive. Right? If events A and B are mutually exclusive and they are exhaustive, those two events are called complementary events. Okay? Right. So mutually exclusive events, exhaustive events are called complementary events. That's what I was rushing to. Okay? So that I've said something about about what complementary events. Okay? So complementary events, two conditions. They must be mutually exclusive. They must be exhaustive. Think about this example that we've been using, the mathematics and mathematical literacy one. It is everyone in the class that is being exhaustive. And then it is, there's no one who's doing mathematics and mathematical literacy that is being mutually exclusive. Okay? And then the probability of picking a learner that is doing mathematics plus picking a learner that is doing mathematical literacy will give us a 1. Probability of A plus probability of B will give us a 1. Okay, so let's end here for today because our time is up, but at least we've introduced you to complementary events. We're going to look further into the concept in our next lessons. Okay, right. Thank you very much, grade 10s, for joining us. I really hope that you have learned something in this lesson, something that you're going to use even in your examinations. Let's meet next week when we do our other lesson. Goodbye for now. Hmm? Hey, hey,